Uh, Hi everyone. Today we are going to discuss about the container orchestrators. Last week we discussed about the I think in the previous sections we discussed about the containers and the container registry and how to manage the containers in Azure web app. Now we can discuss about the container. We can go through the uh, things how container orchestrators will work. This is today agenda. Uh, Kubernetes is one of the famous orchestrator. There are other orchestrators as well. Docker Swarm and Service Fabric as well. Today we are discussing about the Kubernetes overview and Azure Kubernetes service. It's almost similar to the Amazon Elastic Kubernetes service. Is most of the things are similar. Okay, I think we already covered in the previous session: app service, Azure functions, container instances, and last session we discussed about the Azure service container. Today we are going to discuss about these things: Azure Kubernetes service. Yeah, this part and this part. Of course, both are the same thing. Azure Kubernetes service. Uh, okay. Before going to Azure Kubernetes service, first I don't know how many people are aware about the orchestrators and Kubernetes service. So I will give the brief introduction and what are the components in Kubernetes and how Kubernetes will work. Uh, then we can go to the Azure Kubernetes service. Otherwise, it's uh, it's not easy to understand what are the components in Azure Kubernetes service and what are the services or components we can deploy. So better we can go through the Kubernetes components, then we can go to the Azure Kubernetes. Okay, orchestrator. What is orchestrator? Orchestrator is a utility to manage the containers. To manage the suppose any container is down, it will replace with the new container. So uh, instead of a human interaction, it's a kind of some utility to monitor the containers. uh, and it's a kind of a self-healing auto. There are uh, set of features: self-healing, auto scaling, health monitoring, uh, upgrades, rolling upgrades without downtime. We can upgrade the application, and it will maintain the load balancing between the components and the ingress component. We can discuss about all these components, all these features in the coming session. So basically, we can give the one file, how many apps or how many services required uh, to deploy our application. So we will give the configuration file, YAML file. YAML is a mm, declarative language. Uh, it is similar to the JSON, but it's not JavaScript object notation. It's a declarative, human readable data serialization of language. Uh, it will work based on the indentation. Uh, we will go through those things, YAML file as well. So orchestrate is a utility. So it will we can tell the state. We need three apps. We need two apps, two services, to other components, to other components. So orchestrator will decide where to deploy, in which computer it will, which node it is going to deploy, and suppose it is down, it will maintain the state. It will maintain the state. If one of the container is down, it will replace with the new container, new uh, um, Docker container or any container image instance. Okay, this is the Kubernetes for you. Uh, be- uh, this is the this part. This is in this part. This is the actually Kubernetes is a cluster. Cluster is nothing but the group of computers, group of uh, no group of computers or do group of workloads working together to perform the same task. So that is called as a cluster. To suppose here there are three nodes. Node is nothing but a either physical machine or virtual machine or on-premises machine or a cloud virtual machine in the cloud. It's a kind of a compute, one of the compute uh, to compute is a compute instance to maintain the workloads. Okay, here we are seeing the list of nodes, uh, uh, three nodes. We will see what are the components is required in the each node in the coming slide. And here we have the control panel. This control panel will decide uh, where to deploy, where to provision, sorry, where to provisioning uh, instance, uh, uh, container instance. Suppose this node is taking this node uh, resource utilization is more, then it will deploy into the second node, next node. And if one of the container is down, it will replace with the new container. So it will. So all these activities are maintained by the controller plane. In the Kubernetes, we have the two type of nodes. One is a master node, one is a worker node. Uh, Master node will actually we have less resources. We have less resources, but if a cluster is use cluster, very big cluster, then number of master nodes will be increased. But in general, we have only one master node, and more than or minimum we can maintain the three nodes to maintain the load balancing, and minimum we can maintain the three worker nodes. uh, Actually in a Azure Kubernetes service or in a Kubernetes default hosting operating system is Linux, but it will support the Windows containers as well. So if you want to support Windows containers, we need to use the Windows 2016 containers. Okay. uh, okay, I will go just a moment. It is uh, yeah, in the node. Okay, maybe I will. In the node, in the worker node, we need the minimum three components. Not minimum, we need the three components. Kubernetes will maintain the three components. One is Docker container. So we need the Docker container. uh, not only Docker container, any we need the container runtime to run the containers. Second one is kubelet, it may be kube proxy, to communicate between the containers, or to communicate between the other pods in other containers. Okay, pod is also new word for for us. Okay, I will explain that thing also. Suppose this is node. In this node we have the container instance. Sorry, container runtime, the Docker container runtime, and the second one is kube
Hey
proxy.
Rajesh, are you sharing a different screen?
Yes.
I see your PowerPoint only.
Oh, just a moment. Stop sharing. I think it's a problem. I think present view. Okay. Are you able to see my screen?
Yep.
Now?
Good. Yeah. It is.
Okay. 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 In the okay, worker node is a physical machine, either physical machine or virtual machine or VM instance in the cloud or on premises. In this worker in this computer or in this machine, we need the three components. Kubernetes will maintain these three components to communicate with the control plane or a master node. Uh, what are these three components? One is a container runtime to run the containers in the pod. We will discuss what is the pod. Actually, each term is a new word. If we are not aware of the Kubernetes components, we will discuss about the pods. Okay, uh, kube proxy. Kube proxy. What is kube proxy? To communicate between the containers. Or we have the different nodes. This is one node. This is one node, and this is one node, and we have some pods. Uh, Maybe we can consider this is we have one Docker instance running in this node. We have another instance running in other node. Uh, we need to communicate these container instance needs to communicate, so that communication will be established by a kube proxy. And suppose this container instance is going to communicate with the another container instance in the other node. This communication will be established by the kube proxy, and kube proxy responsibility to make the communication between the pods. And there is other component, kubelet. Kubelet is a command that is a uh, that is, kubelet also, that is also inside node, worker node, and it interacts with the pods, and it will start the pod, or it will start the containers inside the pod, and it will stop the pods it will the communication to the container in the pod through the kubelet. It is the process inside the all the worker nodes. So these three processes uh, will be installed in the all the worker nodes. Okay, next one. Where is the uh, where is my uh, I lost tab. Here I have another tab. I lost tab. Where is my is it- I'm stopping again. I think I lost some toolbar. Mm,
Are you also recording, Rajesh?
yes, I'm
Okay.
yeah, I'm recording, but just a moment. I lost something. Just a moment. Yes, I have different tabs, but I lost my it is not showing. No. Mm, yeah, I don't know how I lost that one. Mm, okay, okay. Uh, these three components are these three processes are required in all the worker nodes. So Kubernetes will take care. We don't need to worry, but just we need to know what are the components, or how to communicate services, how to uh, communicate between communication happen between the container instance or nodes. We will get to know. And Kubernetes, there is a master node. We will client will send the request. We need these many containers or these many apps to be deployed. So we have the three worker nodes. So suppose we have the list of worker nodes, but we will decide. We will decide these many containers will be deployed in this node, or we will decide. There are list of components in a master node. Each component has its own responsibility. First one is a Kube API server. Kube API server is a gateway. Uh, it is only one entry for Kubernetes service. It will receive all the instructions, and whatever incoming request, it will validate, and it will store into the and it will process to the it will forward the request to the next processor. So it will validate, and it will save into the etcd. We'll see what is etcd. And controller manager uh, will detect. Suppose we have the container instance is running in the node, but suddenly two containers are down. But our desired state is we need the three container instance. So whenever it will keep on monitor uh, whether desired state is matching or not. So if it is if it, desired state doesn't match the real state or actual state, then it will not do anything. It will notify the scheduler. Just a controller manager will uh, detect if any pod is down, or any instance is down, and scheduler will decide. And scheduler has a capability to replace the existing pod with a new pod, or existing container is existing container instance with a new pod, but it will not replace. Actually, it will determine which node is taking more resources, which node is free, and so based on the status metrics, so it will decide that okay, node one has some memory and cpu. Then it will decide to provision the new node in this one, but it won't communicate. It will communicate through kubelet. uh, and kubelet will start the container. But controller scheduler responsibility will decide where to uh, place the new pod, or replace the existing pod with the new pod. But it will not it is not able to start the instance or pod. And etcd, there is another component, etcd. It's internal storage. Actually, we are sorry, not we, Kubernetes is receiving the instructions uh, from the client or user, but that information where it is stored, there is a memory, internal memory. That is even configuration, security configuration, or configuration values. All the information will store in etcd. It's like a brain. It's like a cluster brain. Even controller manager also always matching the desired state and desired state with actual state. Where controller manager will get the desired state. Desired state will store in the etcd. It's a key value pair. It's an internal storage for Kubernetes. uh, okay. Uh, then we have the set of components. We have set of Kubernetes components. Okay, I will drag one thing. This suppose this is worker node. Inside worker node, we have the three components. Doc, we have Docker, we have maybe container runtime, kubeproxy, and kubelet. That those three components installed and maintained by the Kubernetes. We no need to worry. Just we need to understand how Kubernetes will work. We have three components: kubeproxy and kubelet. Then suppose there is a abstraction. Kubernetes will not build the container instance. It will maintain the abstraction that is called as pod. It will deal with the pod. Even if for deployment purpose, it won't deal with the pod. It will do with the deployment component. But communication between the services and port definition, everything at a pod level, not instance container level. Suppose we have the one pod that is a pod, and in the pod we have the multiple instances, but in general we can maintain the one to one. One pod contains one instance, but one pod contains many instances as well. But that pod is isolated, is a smallest unit of Kubernetes. It's an abstraction over the container. Kubernetes will not master node components or a kubelet or anything will not deal with the container instance directly. It will deal with the pod. Even for specification, deployment configuration specification, we can define the pod. Under pod we can define the what are the component, what are the images are there, we can define. But this is the abstraction. This is a pod is the smallest unit, say abstraction for container. The service, suppose pod is having the IP address. Where is suppose we have the sorry, we have one pod. Pod is having the IP address, but we have two pods to communicate each other. Maybe we have we have another worker node. These pods, these two pods needs to communicate each other based on the with the help of kubeproxy, but based on the IP address only communication will happen. But the life cycle of the pod is not guaranteed. The pod will be destroyed very easily and recreated very quickly. But once pod is destroyed or container is destroyed, we lost the IP address. This is completely isolated. So there is one more abstraction layer. Deployment is one abstraction. Sorry, pod is one abstraction over the container, but there is one more abstraction for static IP. Suppose we have the component. We have another component in Kubernetes, that is a service. A service, it has different kind of types, but this service has static IP, and it will maintain the load balancing. So we need three apps, so it will maintain the load balancing between the these three apps. So we need to maintain the service as well. where is worker node? Yeah, this service is having the static IP. So this master node or other components will interact with the service. Service will decide where to forward the request to the uh, within the cluster IP IP service. Uh, this is one component. There is one more component, uh, deployment. Deployment uh, a service is one abstraction to communication between the pods. It will maintain static IP and load balancing. There is one more abstraction. Suppose we need the we need the same kind of instance, same kind of image. We need three instances. So there is abstraction. Replica set, and there is so we need the three replicas. Uh, so we will not deal with the pods. We can define the deployment. In the deployment, uh, we can specify what is the image, how many replicas we need to when we are going to deploy. So there is one more abstraction, deployment. This is not physical abstraction. This is a abstraction for for the deployment purpose. Go back. So suppose we need to deploy three. It will okay. Uh, hmm, there is one more component, ingress. We are receiving the request from the client or user. No, this is for ingress is a after deployment. Uh, we are going to browse the application, or we are going to communicate the interact with the application. So there is no direct communication from the external world. So incoming request will decide. So incoming request will be routed to the particular service. We have the different services. Incoming request will decide based on the routing rules. It will forward to the specific service. That is the ingress. Uh, it will handle the only incoming request. It's an entry point to the cluster, and it will route to the another service. We will see the how to define these things. And config map. Suppose we need to maintain the some configuration, database connections, and some configurations. Maybe some configuration is not secure. It's not secured, but we need to maintain the some uh, common configuration, because each pod is each instance needs that configuration to communicate to the database or endpoints. So those things we need to define the configuration in the config map. But this is also key value pair. But it will maintain the configuration external to the worker node. So where it will store? It will store into the etcd, the key value store. It won't store in node level. It will store in the master level in the etcd. Those values will be stored. And one more component, uh, secrets. Secrets also one of the it will to suppose we want to store the any secret information like username, password, or any secure information. We need to store in the secret component. it is exactly same, but it will save, it will store the encrypted data, but it will save normal data, normal text format in etcd. And volumes, suppose this data in Docker instances uh, is not permanent. Once instance is down or destroyed, we lost the data. So to maintain the uh, to maintain the state or database files or file shares, any files, we need to maintain the volumes from external to the Kubernetes cluster. That is common. That is the common uh, share between the uh, mm, uh, between the container instances or between the pods. And the last one is namespaces. Yeah, there is a lot of descriptive things, but we need to understand these things uh, to go to define the components in the ML file. Namespaces. Namespaces uh, it is organizing the resources. If you define the resources, it will define by default namespace. So to secure our environment, to secure our component, suppose to differentiate the two different environments. Suppose two teams are I'm working in one team. I have dev components and server as test components, but we have the only one cluster uh, development purpose and testing purpose. We can define the components in different uh, namespace. So we can isolate the components. And one more thing, two teams are parallelly working. uh, uh, one team is working on the set of microservices, another team is working on the set of microservices. We can segregate the components by using the namespaces. And even security, other teams by mistake they cannot delete, or so in that case we can even Azure Kubernetes service or Elastic Kubernetes service, they can maintain the security, role-based security at namespace level. That is the purpose. We can define the namespace. If we didn't define the namespace, it will consider default namespace. Okay. There is one more thing. Stateful set deployment. uh, Deployment is having the replica set, but it is not stateful. But if you want to maintain the stateful, why we need the stateful set? Suppose database. See, if you define that any database in the container instance, that will be destroyed. We lost the data, so we can keep the database or any data external to the Kubernetes cluster, and we can define one a container or a pod to communicate to the external database. Uh, but we can minimize the writes, and we can maximize the reads. So we can define the one pod for one pod is having the static IP. The static we can directly communicating with that write pod. We are directly communicating the pod which is having the write access, write provision to the database, and uh, we can use the service load balancer for read access. So in that case, we need the stateful set to define the state. Uh, in this scenario, we can use the headless cluster IP. There are three type of services. We define, I think service is a abstraction layer on the pod in communication, right? We have three type of services. Suppose we have a client request. This request will comes to the service will decide which pod is going to serve this request. Then why we need a service is each pod has its own IP address, but once pod is destroyed, we lost the IP address. So we have the load balancer. Even pod is lost. Controller from a master node will replace with the new pod, but still we have the static IP. This will maintain the IP range. Service will maintain the IP range, so it will communicate with the each pod. Okay. There are three. Okay, I think we can go to the presentation. Yes. I think yeah, yeah, we can go to the yeah. Okay, now so now we have master node, worker node. We have a master node and a worker node. How to communicate to the Kubernetes cluster? This is a Kubernetes cluster. In the Kubernetes cluster, master node, which is having the set of components, and worker node set of components, and we are going to deploy some components on worker nodes. So we are not dealing with worker nodes. We are interaction with the cube APS server. Uh, but how to communicate with the cube APS server? We have three options. One is a kubectl, or a kube control, or kubectl. People call it as different names, but where is this? We will give the configuration to the Kube API server through different ways. One is kubectl, that is the way we are going to communicate. That is a CLI utility. We will communicate with the kubectl. We can communicate through portal, or we can communicate through dashboard. There are APIs, but maximum we can communicate with the kubectl. Kubectl is a very powerful utility. Uh, okay, we will communicate through by using kubectl. We can interaction with the kube API server. Okay, we need 5 applications to be deployed on this in 3 nodes. But uh, in the local, how we need to work? Kubernetes, installing Kubernetes server in local, we can we need to install the Kubernetes cluster, but production cluster is very used one. Our desktop workload is sorry, our development or testing workload is very small workloads. It's not possible to install. So there is a other open source project, Minikube. There are two. If you see my if you see here, uh, I think there are two ways to communicate Cube API server. One is Minikube. Minikube is a open source project to maintain the local Kubernetes cluster. This is used for development purpose and uh, uh, testing purpose. It will support all the OSs, Linux, Mac OS, and Windows. I already installed this. There are set of instructions we can follow, but in Windows we have exe. We can download the Minikube. We can install the Minikube. There is other way also. If you Minikube will create the virtual environment. It will run on hypervisor, Hyper-V. Uh, at the same time, Docker also will support. In Windows, Docker will support. Earlier we saw that a Docker desktop to run the Docker in Windows. We need to install the Docker desktop. If you see that Docker right click, settings. That is,
Hey Rajesh, sorry to just interrupt. Just wanted to check how many of you actually know Kubernetes and Docker.
sorry.
I don't. It's all new to me.
Uh, if people are already aware of Kubernetes and Dockers, then I can move to the direct Azure Kubernetes service. That is the reason I'm explaining the basic what are the main components in Kubernetes, how Kubernetes will work. Hello? Okay, it is.
Hey man, sorry, something happened over here and I got disconnected as soon as I.
Okay, there is a way to work with Kubernetes in local with in the Docker desktop. There is option you can enable the Kubernetes. It will create the single node. In the same node. It's there is a virtual node. It will maintain the Kubernetes. Okay, I will remove this one. I will remove, apply, reset. I will show you. Uh, I'm clearing all the. Where is the, just a moment. Okay, I'm just Docker PS will give the Docker instances, running instances. If I manage a queue, okay, these are the running instances. Minikube. So currently Minikube is running. I'm stopping Minikube. One moment. Okay. Then Docker PS minus a queue. It will give all the IDs. Okay, I think it is running on the this contest. Docker uh, desktop. Currently, Docker desktop. What is that? I'm enabling Kubernetes again.
Good way to learn Kubernetes will be that if you Google, there is a Kubernetes the hard way, and there is a GitHub repository. Kubernetes the hard way. In that case, it will tell you how to install each and everything manually.
Minikube. It is going to create some virtual box for control plane node or master node, and it will install the Docker also. Whenever I start the Minikube, a context will change to Docker desktop to minikube. Then we can see the instances kubectl. Kubectl is having the set of commands. Kubectl get pod, it will give the all the pods. Kubectl get service, it will give the services. Get deployment, get nodes, uh, get pods. There are already running this. Already two pods are running in this minikube. Earlier I installed. Okay, I will delete everything. I can okay at deployment. I cannot directly interact with the pods. Even if I delete the pods, it will create the Kubernetes will create the new instance. Okay, deployment. Deleted. Then no, no. It's still terminating. Okay, terminated. Okay. Now I'm going to create the deployment. How it will work? If I just specify the image and deployment, it will create. It will use the all the existing uh, 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 properties to create the deployment. I'm creating the deployment by using the kubectl. Create. No, suppose that is the name of the deployment. Uh, Image. So it is going to download the image from the Docker app, and it will create the pods. Now I'm not specifying any how many pods are required. I'm not saying anything. Just I'm specifying the image name and deployment name. Deployment is created. Get pod. No. So one deployment is created and one pod is created. This is using same name with some IDs. Still creating. It's not created. Yeah, it is created, completed. So suppose I want to see the output. What is the state? What is the deployment value? I will just keep that. But generally, just for the demo purpose, I'm showing this one. Generally, we will not work. We will not create the deployment or pods in this way. We will create. We need to provide the set of values, set of properties to specify the specifications, set of specifications to define the image, to define the deployments and IP addresses and, in the config file, not through command prompt. Deployment kubectl edit. Uh, uh,
Do you have a YAML file?
no. YAML file I didn't create it. I'm going to create. Just a moment. I think this name is wrong. Just a moment. This one. It will open the YAML file, and actually we need to specify all the properties. But I didn't, for demo purpose, I didn't specify anything. Just I specify the one image name, but it uses all the uh, 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 predefined values and to create the uh, deployment. Suppose I want to in this one replica is 1. Now I'm changing to 3. Save. Save. Deployment is done. Get pods. It is going to create the 3. Okay. Now out we saw that how to create the pod and deployment. Then I will create the. I will go to the. Okay. Test. There are some yeah, writing YAML file is no need to write manually. There are some certain tools or certain extensions. We can use uh, extensions, Kubernetes. There is templates. I'm using Kubernetes. This one I'm using. If you okay, go to the. I'm creating the new one. Just NGIX. There is a specification we need to follow. Here, in the deployment is a blueprint for the uh, 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 specific pod. Uh, Here there is a specification template. This is the blueprint. The deployment is having the. This is the metadata. This is metadata information. This is the blueprint information specifications, and there is one more component for deployment. There is a state. This is the current. This is the desired state, but the current state will be stored in the etcd. Then it will compare, and it will deploy the delta. Kubernetes will control scheduler will deploy the only delta. Controller will decide. Okay. Here I'm going to define the component. Suppose name is NGS deployment NGNX. Uh, Here we need to follow some naming conventions. This is also label is okay. Specification. This should be match. This it will it will find that selector based on the selector. It will they set the blueprint, template. Then there is a one and a container. Rest of the things I'm not touching anything. Everything is okay. I think even it's not required for me. I am removing everything. Just ports are required. It's resource. Everything is okay. Okay, but it will. If I okay, I will deploy this one. Uh, okay, I will use the terminal. To terminal. Giving file configuration file. Uh, Nginx deployment is invalid. Map, yeah, my map selector. Yeah, this is the one. Yeah, created. Ctl get deployments. This is the deployment we did. Nginx deploy one node. Kubectl get pods. Yeah, this is the one created now. And just we are using nginx deployment. This is the one created. Okay, then actually we are now I'm going to create the one more thing. Just nginx service. I'm going to deploy the service component. Service config. Actually, I can write the service set of YAML files in the same file. It is not a problem. Uh, for a demo purpose, I'm defining the another to show the differences to service. So this is metadata and the year is specification. Here in this specification, when this one should match this selector should match with this name container name. Here I give the nginx. Okay, I'm giving nginx service name by default. If I didn't specify the namespace, even if I didn't specify it is considered a default. If I want to specify, if I want to define explicitly, I can define the new namespace. New namespace, if it doesn't exist, it will create. anyway, even if I didn't use this one, it will create under the new default namespace only. Okay, service specification. Okay, this is nginx. It should be equal. And type is, if we by default cluster IP, even if it didn't specify the cluster IP only, port, I think the name is not required for me. This port, I'm using 3030. Target port is 8080. uh, I'm not specifying the node port, I think. Yeah, I think this is array.
But that is fine. Yeah, you have to give a tab under target port. Remove that single tab on under the port. It doesn't need a dash because it is part of the previous section only. Something like
This is okay.
Okay.
It's okay. Okay, now I'm going to deploy this service. So it will, as of now, okay, I will maximize this one. Get no, this one. It will tell us which node. This is IP, and it will tell all the information. Or maybe just a moment. Clear. Uh, ours. This is the one. Uh, describe. Describe this part. Now where is that? This is the container ID. This is the IP address. I'm not able to see port.
It's there 8080/TCP nginx lower.
Yeah. This is the sorry. This is it is running under 8080. Okay. Now we are going to deploy. Cattle. Apply. Yeah, first time it is create, but apply will meant if it is not there, it will update as well. Apply. Uh, and service. Okay, created. Uh, get services. Ours is this one. nginx service. Uh, if you see, this is a 303. It is running on 3030. Minimize 3030, but it is targeted to the 8080. If I ask the explanation or describe it, uh,
kubectl.
describe
It's KUBE. Sorry.
Okay, Cube is a typo. Sorry. Cube
Yeah.
describe and service nginx service. Okay, maximize. It is target port is 8080. It is so okay. Now it is running. It is using the IP. Sorry, it is using the 10.103.227.52. Now I'm going to increase the replicas. Now we have one replica. I will maybe 5 replicas. Then I will refresh and get where is this one. Save.
You have to apply. It's already
Yeah,
created,
yeah,
right?
yeah. This is yeah.
So that is the
That
one
is
of the tip when you do scripting, you always do apply.
apply. Yeah, always apply. Yes.
Yes. If it is not there, it will create.
Yeah. Keep getting. Yes. Yeah. It created. It is updated. Then we can see that keep get pods. We requested 3. If we requested 5, this is 1, 2, 3, 4, 5, and we can ask why. What is the IP addresses? Output. Yeah, sorry. Here we can see that it is using the same series. It is 172 some series it is using. It is using the Q character.
This is all local host, right? So
Yeah,
172
it says it
is
is
all
using the
local host.
same node. You see, it is running in the single node. The uh, get services. Oh, yeah, describe service. Describe service. This name service.
Yeah, this is good. The 10 is basically internal private IP. So all these three are basically 192, 172, or 10 series. They are all private IPs.
Yeah. Okay, this is the this is the way to define the components in the YAML file. So now I'm going to create the Docker image and a YAML file, and I will deploy the I will create the Azure Kubernetes cluster. Then I will deploy the components into the Azure Kubernetes cluster. Okay, before going to that one, I will switch to the presentation again. I think we already covered these parts. I think, yeah, we already covered all the what is pod, what is service, stateful set, configuration map, everything we covered. But I didn't show the demo because of time. I need to cover other things. Um, okay, Kubernetes. I will come to this slide again. And this Kubernetes service. Yeah, Azure Kubernetes service. So Kubernetes basically Kubernetes is a open source uh, orchestrator from Google. Uh, it is free, but Azure Kubernetes, we are running Kubernetes cluster in the cloud. If you are using Azure, it's a Azure Kubernetes service. If you are using AWS, AWS is also supporting the Kubernetes. That is a Elastic EKS, Elastic Kubernetes service. Now I'm going to the Azure Kubernetes service. Azure Kubernetes service is a managed Kubernetes service, a managed Kubernetes cluster in Azure like EKS. Control panel is free. Microsoft won't charge for control panel. We need to pay only for uh, worker nodes. uh, how many worker nodes we requested, we need to pay only for the worker nodes, not for the control panel. Control plane. Control plane is a free. It will maintained by the Microsoft. It will create the master node. If it is based on the worker node number of worker nodes, they will increase the master node nodes count as well. It we no need to work. Actually, whatever I showed, that is the basic level and low level things. How Kubernetes will work and how to create the deployment. But we are mainly work with the YAML file. We can even we can define the multiple YAML files if you just hyphen dash dash. No need to define other file, and we can define all the components in single file. Uh, uh, just I think okay. What is the advantage with the Azure Kubernetes service or any cloud Kubernetes service? What is the advantage maintain the Kubernetes service in the cloud? What are the features they are offering? Azure in the Azure is a service, Azure monitor. It will monitor all the disks and Azure files, so we can monitor all the Kubernetes volumes or shares, or what are the events are happening in the uh, uh, worker nodes, and identity and security. So suppose role-based access control by using the Active Directory. Azure is having the identity system, Azure Active Directory in the cloud. So in the Azure Active Directory is having a list of users group and roles. We can map the specific roles to the specific users. Uh, Not only that one, at the namespace level. If you see that whatever components I defined, those components will be created under get namespace. I think I need to give namespace also. I think. Yeah, namespace is default. Whatever I created, those are created under a default namespace. If I explicitly define the namespace here, it will create under a particular namespace. In the Azure, we can where is that presentation? We, uh, we can define the security at a namespace level as well, based on the roles defined in the Azure Active Directory. And Azure Monitor is a monitoring service in Azure Azure Cloud. We can see all the logs. What are the logs? And it will support the two type of scalings: uh, pod scaling, horizontal pod scaler, horizontal pod scaling. What it will do? Suppose three. Replicas, currently 5 replicas we requested. We want to increase the pods. We can increase the count. So pod, there is a service, a horizontal pod is scalar. It will monitor the desired state and actual state, and if it sorry, it will monitor by the control manager, and it will tell that it needs to increase. So horizontal pod scalar will increase the count, number of counts. And a virtual network. Uh, so we can define the virtual network in the Azure. We can run the Kubernetes under Azure virtual network to maintain the private cluster. It will inbuilt. It will support the ingress with the HTTP application routing support. So ingress is a income. Ingress is a component in a Kubernetes. It will handle the incoming request. it will route to the specific service based on the routing rules. So by default, it will support the ingress HTTP application routing routing. But no need to install the any other components. NGINX, it will support the NGX inbuilt ingress component, and it will support pull the images. Suppose pod uh, to deploy the pod, we need the image. That image, we need to pull it from the some registry. It will support the Azure container registry and public registry, all the public and private registries as well. Even Docker and Azure container registry, we can easily pull to avoid the ingress traffic from cloud. Most of the time we can use in Azure container registry. Elastic scale with Azure container instances. Actually, in the previous session, we created the Azure container instance based on the image in the Azure container registry. We can create the container instance. We can increase the uh, number of instances, Azure container instances, uh, by using Azure Kubernetes for Azure container instance. How to for a development machine, how to work with the Azure Kubernetes. No need to actually. Earlier I showed Docker Desktop and Minikube. Those are the two things to work Kubernetes in a dev or a test environment. Even Azure also will support. This is one of the applications. If you see that there is a other thing, Azure DevOps, sorry, Dev Spaces. Azure Kubernetes will support Azure Dev Spaces. It is isolated environment to work with the cloud Kubernetes to work with cloud Kubernetes cluster from development machine. It will support in Visual Studio and Visual Studio Code. In the Visual Studio Code also there is a option. I think this is, yeah, this is here we can connect to dev spaces. I think not sure. Here we can connect to the dev spaces, specific dev space. So it will create the bridge to the Kubernetes. But this dev spaces is uh, going to expire. Uh, it is replaced by the bridge to the Kubernetes. Uh, okay. Okay. So still YAML files we can maintain in the source repositories, but still there is a for to maintain the images we have the Docker Hub or Azure Container Registry. In the still we can maintain the YAML files in a repository, but if to distribute the YAML files, we have the package manager for Kubernetes. We can we can package all the YAML files, and we can publish to the Helm hub. It will main Helm in the Helm hub is creating the it will maintain the Helm chart. Helm chart is having the folder structure like this. This is the Helm chart name, and this is the Helm chart YAML file. This is the meta information. What are the Helm files are what are the YAML files are there in the template. and what are the in the values will be uh, replaced. Suppose it will be uh, this is having this is like a configuration for the Elm files, uh, and suppose if suppose we have the two different teams in the organization, we can maintain the Elm repository, uh, sorry, Elm pack repository at a uh, organization level, private repository and public repository. Suppose to distribute the YAML files between the two teams, we can use this Elm repository. Already existing YAML file, no need to create the YAML file, and no need to work on YAML file. We can redistribute the YAML files by using the Elm package manager for Kubernetes. I'm not showing this one. Yeah, this okay. This one. I'm going to create one Kubernetes cluster in Azure. Go to the cluster. Okay. Go. Sorry. Go to the portal. Kubernetes. Create. For demo purpose, I'm using only one zone. I'm not using the availability zone. Okay, I'm using only one node. It will create the one of worker node. Master node we no need to specify. Suppose it is running on Linux. This is a node pool. Authenticate. These are the service principle for authentication purpose, and this is the role-based access. I'm not touching anything. Even I'm using the existing networking. Then review and create. It will take some time. It will take some time to create the cluster in Kubernetes. So meanwhile, I will do one thing. I created the two applications. There is core web app. I created two applications today morning. This is the Blazor application, single page application in .NET. If I added some features, I changed some values here. Some environment variables. I added some environment variables here. Properties. Created some environment variables. Now I create there is this is Docker. This is a Docker file. What I think we already gone through this Docker file in the previous session. It is pulling the base image from the Docker hub, and it is building the code, and it is copying the output to the published directory, and it will start the application by using the entry point. Okay, now I'm running application locally, and there is one more application. Let's this is also same thing. I just changed the where is the views in the view. shared view, not shared the index. I did some changes. I need to use the hosting environment and to know the IP address, running IP address. I inject these two uh, variables. So I changed the startup file. In the startup file, I added this one singleton services singleton. This is not related to the this demo. This is related to the .NET Core functionality. Uh, to this is the dependency injection. It will inject the object. So I'm running this application also. It is okay. My Blazor application is running in local. My local. Uh, I will run the Docker. Sorry, I will run the web application as well. If I see the containers, Docker, yes, this is one application. This is Core Web App, and this is Blazor Server App. These are the two applications running in these two applications running. Sorry, these two instances running for these two. I think I remove this breakpoint. Fine. So locally it is running. So I define the so this Docker image is created locally, and by using Docker image, those Docker images, it created the instance. This is the instance for Core Web App, and this is the instance for Blazor Server App. Blazor Server App, Docker image. Okay, if no, I think this one, Blazor Server App, Blazor Server Dev, and Core Web Dev. These are the two. Okay, I will do. Uh, these are created 2 hours back. The same thing. It is created before session. I tested this one. I created, but it is not doing anything. So I will do one thing. Yeah, it is using the same image, and there is no change. So that is the reason there is no change in the layer. So it is using the same image. I will do one thing. I will draw. I will remove those images, and I will create images again just for a demo purpose. Here, Docker. Uh, yes, Docker. Uh, Docker. Yes, check it. It is going to, yeah, it's fine. It's running. Now there is no running instances. Docker images. Docker. Right. And Docker. What is it? Yeah, okay. I'm clearing. I'm cleaning everything. It's not required. Just show the difference. It is. It was already created. There is no difference. That is the reason it is not created. Okay, those are related to the Docker desktop. Nothing is related to these two apps. So now I'm going to create orchestration. Okay. Where is that? Yeah, this one. Go to the. I define the Docker compose. Just I will show you. Just I define the Docker compose to build the Docker images, multiple Docker images to these two apps, core web app and core sorry, pleasure app. Then I'm running in detach mode. Sorry, there's a. So it is going to be, building the Docker images and it will create. It is not exist. Yeah, this is the one. It is going to create the one image, and it is the this is the port number. So and this Blazor app it is going to run on a 4000 I think 40,080. Okay, then I will after it is completed. I think. But still running, still building the Blazor app. So first time only it will take this much time. Next time it won't take. It won't build again. It is creating the images. Okay, Docker image images. These are the images. Demo file, Azure Kubernetes Blazor app, and okay, these two are images created just 17 seconds before. Okay, now I'm going to use. I'm. This is different port. This is different port. I'm using localhost. There is a port number 30,080. Yeah. So it is running up and running. This is web app, .NET web app, and okay, there is 40,000 and 40,000. This Blazor app is running. So I'm going. The images are created in my local. Now I'm going to push the image to the registry. Then I will create the I will push the I will create the YAML file and push the image. Sorry, I will create the YAML file to deploy these two applications in Kubernetes service. Just a moment. I will go to the command prompt. There is a Azure command line interface. AZ login. I think I already login. Just I will make sure. I log in. I connect to my Azure account. What is it doing? Not doing anything. Yeah, it is doing. Yeah. Okay. Okay. I already connected Azure account. Okay. Okay. Then go to the portal. What is my? I think it is completed. Go to. This is the resource group I'm using for Kubernetes. Uh, Sorry. Just define the variable. I'm going to define another variable, ACR resource group, Azure Container Registry resource group. I will think that is this one. I think container registry. Where is the? I didn't see. Okay. Registry. Where is that container? Yeah, this is the container. I think this is the one. This is the name. I need the resource group as well. This is the resource group. Then location. I think location is not. I'm not going to create any no group or no container registry. So location is not required. Okay, this is fine. Then I will connect to the Azure Azure Container Registry login. I think resource name also this container registry name also required. ACR. Okay. ACR login name ACR. It is going to connect to the container registry. So like a Docker, how we will connect to the Docker login, it will connect to the Docker hub. It is the same thing. It's a private registry. Then I can see the Docker images. It will see the it will show the local images anyway. Uh, so now I need the login. I need the login name for login server name for the Azure Container Registry. Yeah, login jet list uh, resource group a resource group. I will see that what no. I think this is it. It's not login name. It returned a very big JSON file. Okay. Then I need this information. This login server name. Where is to push the image? I need this information. Login server name. I think this is the one. I need this information. So I'm going to pick that value. Yes, yeah, login server name query. This is a login. Okay, then login. Yeah, this is the one. Then I will Docker images. I'm going to push the image. Docker images. Yeah, this is the name and this is the tag. I am going to create the new tag and I will push the image to the Docker container registry. Docker, Docker tag. Latest. I'm using login server. I will use the same name. Use the same. This is Blazor app. This is, I'm going to create the another tag for web app. Okay, I think already web app is there. Last time I created, so giving for web app. Okay, yes. Yeah, this is created. This is core web app is created. Okay, then Docker push. I think container. This is container registry repositories. I currently those Blazor app is already there. Oh, okay, I will create another tag for this one. It will replace anyway. Don't want to restrict the existing one. Server app. Okay. Okay. Then now I will push the image to the Docker container registry. Docker push and login server. Where is the Blazor app? Image doesn't exist. Oh, sorry, this is wrong. I think I gave double tap. Both are same. Yeah, it is going to push the image to the container registry. See, in the same way, I will use Docker push Blazor server app, core web app. I'm almost finished. It will take another 5 to 10 minutes. It's not 5 to 10. It will take 10 minutes. Correct. So this core web app and blazor server app are created. So now I'm using. I'm not creating a YAML file. I'm using the existing one. Go to the container one. I will use. I'm copying from existing one. I'll change YAML file. Anyway, I will close this one. This one. Okay, I will change this YAML file to push the image. This one. No, don't share. This is not required. Okay, I will. This is deployment. This is service. Yeah, this is a another deployment. Okay, exactly same. Okay, I'm using. Where is this is just I copy all the names and I'm using the image. I'm using this image. Where is this? What is this? I'm using this one. Just I define the environment variable. I can use this one. What is this? Currently added removed at least.
Hey guys, I have to drop. I got some work.
Running environment. Yeah. That's not a problem. Anyway, Cube, I'm using same name. Service load balancer. Yeah, so actually service types are three different types. One is cluster IP, and one is node service. Other one is a load balancer. Load balancer is a external IP. It will create the external IP. Uh, this is an extension of a node IP. And whenever we are deploying to the cloud provider will create the external IP. So we can use the load balancer instead of cluster IP. We can use the load balancer. I'm using, okay. This is the this one should match with this one. First I will deploy one, then I will deploy next one. Save. Yeah. Uh, Go to the command terminal. Go to the terminal. Command prompt terminal. AZAS install CLI. Start required. Already I have cubes cattle in my local. Yeah, kube cattle is already there. Anyway, AZAKS get credentials. Then if you observe that here it is showing only Kubernetes. It is showing something else. I think this was anyway. This was destroyed. Only Docker desktop and Minikube. This is not working. Now it will change now. Get credentials. Source resource group. I think I created resource group here. I will use this one only instead of creating resource. Yeah, I have a resource group, and yeah, everything is there. And I will create the AKS cluster as well. AKS cluster. What is the name? AKS cluster. This is the one I created. Yes. Resource group. Resource group. Yeah. AKS cluster. It will download the credentials and it will change the context now. Cluster context. Yeah, it is updated the context in my config local Kubernetes config. If you see that the current context is Kubernetes. Yeah, this is the one. This is a new one. Okay. Get nodes. I created only one node. Cube cattle. Get nodes. Yeah, there is only one node we created, and that's it. Apply file in this location. Not in this location. This is the one. Cattle. -f file deploy config file. Deployment is created, service is also created. Okay. Get services. Get service. Wow. Always in queue carry. Yeah, load balancer is created. 80, it is running on 80 and it is point to the 30,437. Okay. This is our okay. Now it is created. Get pods. Only one pod is created. Okay. Now I will run this one.
That pod has an issue. Error image pull. Check if it is running now.
I think yeah, this is not running. Actually, that is pull. While pulling it has a problem. I think. Yeah.
Yeah, run again. Maybe it is still working or something. I don't know.
Yeah, it is working now. Pull back. No, it is not working. I think none of one 0 out of 1. So it is.
Yeah, it is still trying to get image. I don't
Image.
know, like image. Yeah, image path might be some issue.
Image path. This is the one. Yeah, image path is some issue. Yes, you are right. Go to the image content registry, repositories, core web app. This is the one. Just pull it. Image is up to date. Okay. Then why it is not?
Check in the file if it is the same name or
yeah, same name.
type.
Yeah, maybe typo. Yeah. I didn't see any difference, but let us try again. Demo. Unchanged. Yeah.
First one is configured. Is it like applying something?
Yeah, it's applied. It's applied. Yeah, service I didn't change anything. The deployment only I changed. Yeah,
right. There's something like it is showing something on the pod side.
Yeah, pod. No, still some issue.
Is that the error that we are seeing in the limits section in the YAML? Can you go back to the YAML? So the limits that you have defined, it is erroring out.
Anyway, this is not required anyway. I will remove this one.
Yeah, remove that, and it looks like there might be some issue.
This is
It's
just
like that. It is complaining about the tabs.
Yeah, it's indentation problem. It's indentation problem. Content.
So image ports, container ports should be, so environment.
It's exactly same. Same. I didn't change anything actually.
No, the name wise, I think there's no issue with the name.
I think some format, indentation problem. I think.
Indentation issue. Maybe you can put it into something that can.
YAML validator.
What if you? Yeah. Okay. Do that. It's okay. I thought like it was giving us some kind of reformatter in Visual Studio Code. That's what I was. No, over here itself. Go back. Hover over this.
I think there's a space, additional spaces.
You just hover over it. It will give you error. No, hover over the line, squiggly lines, and just a simple line. Don't put on some keyword, otherwise it will start giving you help. Just hover over on line, maybe line 25. So, okay, it is not giving you that. I thought like it is giving you a quick fix.
Field is optional to value.
Just put it to some formatter, YAML formatter online. So yeah, if you put the CPU and the limit should be under resource. So under resources, there should be limits. Okay, this is good.
No memory limit for this container.
You need to define memory also. Put a memory. CPU, you have defined request CPU, but limits, maybe you define memory and CPU both. Put a memory line along with, yeah, memory, colon, maybe 128 or all small, colon, space. And in quotes, you can put 128 MI in quotes. M capital, I small. Yeah. Okay, that's fine. Does it?
Doesn't complete anything. But problem is it's some authentication issue here. It is not pulling.
Okay.
Okay, I will save it. And,
let's see if it works or not.
Request is invalid. Unchanged. Service is unchanged.
Maybe I'm unable to know. So M is capital in quotes. Put everything in quotes. 128 MI in quotes and M capital. No. The whole 128 MI in quotes.
Okay.
Yeah. Okay. Let's see.
Kubectl. Kubectl apply. Created. Okay. Kubectl. Check. I think same problem. I think some problem with my credentials. Just a moment. I think I understood. I think I need to get the credentials again. Just I will log in again. Oh. I think I pushed right. Docker pull. Okay, I will. ACR. Even this is also not working. So something wrong with my container registry credentials login. Yeah, it's the same problem. Okay. ACR. Login. Yeah.
You have to say
AKS. That's ACR. Okay, for this one. It will take some time. Uh, Meanwhile, I will I will update this YAML file. This is service, the deployment apps. One, this is a ledger app. This is a pleasure app. Pleasure app. Pleasure app. Better I will check in images. Images. Pleasure app. I think pleasure server app. This is container registry. Where is depositories? Places server app. Go to this one and places server app. Let us okay. Running in AKS 85 in AKS. I think places app. Yeah, okay, I think it seems okay. Save. And okay, it is not showing anything. It's not exist. Yes. Oh. Created. Okay, fine. Kubectl. Maximize Kubectl. Get power. Yeah, it's up and running. Okay, it's fine. Now Kubectl. Get services. So this is the core app. This is the external IP. Yeah, it's running on an AKS. Fine. This is Blazor app. Yeah, that's fine. Now I will go to increase the. Now I'm going to increase. Currently, how many pods? Only one pod is running for each one. I'm going to create the horizontal. Uh, uh, mm, I'm going to scale the pods. There is only one pod. Instead of I will scale kubectl. Deployment. Mm, Deployment. Scale. Okay. Kubectl pod. It is scaled. Okay. Now it is manually scaled. Now I am going to configure auto scale. Kubectl auto scale. Auto scale deployment. deployment. You can choose this one. Autoscale. Deployment. CPU. 50%. Minimum 3. And maximum. That's just percent. Now autoscale is enabled. There is another way we can create the horizontal scale as well. Can create Azure horizontal pod scale. Horizontal auto scale. Kubernetes. Origin. Specification. Name deployment. This is here. This is the one. This is Okay. Created. Create catalog. Yeah. Yeah. This was created. These two are created now, and this was created later, earlier. And there is other. We need to increase the node also. Scale the nodes. Kubectl. There is only one node. I will increase to kubectl. AKS. I think I have here. Source. Yeah, this is correct. Source. Source queue. AKS cluster node. It will take some time to increase the node, to scale the nodes to 3. It will take some time. It will take some time. So scaling front end is node scaling is created done to 3 nodes. Kubectl. Oh, kubectl get nodes. Yeah, 3 nodes now. It is increased from one node to 3. It is scaled to 3 nodes. Now autoscale is implemented. So demo. So then I can see the what is the version of image. What is the version AKS AKS show resource group name. Version is 1.17.13. Now I'm going to increase the version. Upgrade the cluster version. 1.18.18.8, when it will take some time. I'm going to upgrade cluster, upgrade the cluster with this version number. Are you sure you want to perform this operation? Yes. Yeah, sure. We will upgrade the control panel and I not walls. Yes. It will take some time. I'm pausing the video. And Kubernetes upgradation is completed. Version upgrade is completed. Then we can see the version upgrade. Yeah, version is upgraded to 1.1.18.8. Then I'm going to clean the resources. Whatever whatever I created, I'm going to I'm going to delete the resource group. It is going to delete the Azure Kubernetes cluster. Uh, that's it. Thank you for joining. Thank you everyone. Thanks.